All right, let's get it started. Good afternoon. Thank you for coming for this session. And right now, I'm going to talk about the next big thing in the Java space, coding that sparks joy with Quarkus. I don't know how many of you know Maria Kondo. Okay, some of you, yeah, sparks joy, I stole from her. But basically, I want to mean that there are some practices in the Java world, like, for example, being fat and being slow. This thing should be put in the past because with Quarkus, you should only keep the things that spark joy in your life as a developer. That's why we're talking about coding that sparks joy. And some quick facts about me. My Twitter handle is @Yanaga. I'm a Brazilian Japanese, and I'm also a Java champion and a Microsoft MVP. But I've been doing Java development in the past 25 years, and I just realized that Java developers are very good in social media because Java developers, they have a lot of available time. So every time you don't want to work or you want to do some tweeting, Snapchatting, Facebooking, or Instagramming, you just decided to run a Maven build. And then you have like 30 minutes of available time for you to go to the restroom, get some coffee, and of course, check your social media. That's why Java developers are very good because we always have to wait a long time. So whenever we want to test something in our application, if you want to see the results that of what we're doing, we have to, well, let's run a Maven build, Maven clean, build the artifact, package it, stop my application server, remove the artifacts, copy the artifacts, start the application servers. 30 minutes later, well, you just issue a request to your browser, and then you wait another 5 minutes for it to warm up. You know that, oops, I made a typo. So I did something wrong. That's why Java traditionally has a low productivity because we have a very bad inner feedback loop. But as I said, Java used to be this way because Quarkus is changing the way that we develop Java applications. Quarkus is pure and simply developer joy because with Quarkus, we don't have to be jealous anymore about JavaScript developers, well, not that much, but PHP developers and Ruby on Rails developers, for example, because they used to be able to save their files and automatically see the results of the work. But thanks to Quarkus, we as Java developers, we can do the same automatically. But instead of just talking about what we can do about Quarkus, I want to show you what you can do with Quarkus. So let's go to our new favorite website on the internet. So you can go to quarkus.io, but I want to start here with code.quarkus.io. So if you want to start coding with Quarkus today, you can go to this website, code.quarkus.io, and generate your very first project. So if you ever created any Maven build, you know that you have to specify, for example, the group ID, con Red Hat developers, and of course, artifact ID. Let's try to give a name, Devoxx Ukraine. And let's try to add some dependencies. I want to create first a very simple REST endpoint using JSON. So I'll add this dependency. And it should be good enough. So I click that button, generate. It's going to download the zip file for me. And that's when the magic starts. So I'm going here to my terminal. I'm going to unzip that application. So I have this Devoxx Ukraine folder. I'm going to open my favorite IDE. So it's very easy. I already have my project here up and running. So how does the Quarkus magic work? Well, everything happens when you type these magic commands, mvn compile Quarkus :dev. So here I'm starting the development of Quarkus. What is happening is Quarkus behind the scenes is monitoring my file system for changes. So whenever I issue a new request to my server, Quarkus is going to rebuild my project and restart the server. And everything will look just like magic. So how long did my Quarkus application took to start? 800 milliseconds. You might argue that it's fast enough, but I know that we can improve. And the more you run Quarkus, the faster it gets. So let's try to see if my application is running. If I go here to localhost, yes, my new cloud native application is ready. And if I issue a request to /hello, I have a simple, very simple hello world endpoint. So let's go back to here to my IDE and open the hello resource. the example resource. So here I have this plain old static string hello, but let's try to change it on the fly. Just because I'm Brazilian, I'm going to say olá, which is hello in Portuguese and Spanish too. I save the file, go back to my browser, and it's already there. How long did Quarkus take to reload? Let's check. This time we took 500 milliseconds, but again, as I said before, we can do better than that. We can be faster than 500 milliseconds. What else can we do about that? You could say, well, it's just boring giving this plain static string. Maybe we should have a configure property so I can dynamically change this and return the greeting that I want. So I go back here, create a property, string greeting. And thanks to the microprofile config API, I can say, well, let's try to do a config property. And the name of the property should be something like greeting. And instead of returning hola, I want to return greeting. And I save the file, go back to my browser, refresh, and oops, I have an error. Because I said, well, you specified the configuration property called greeting, but you didn't specify the property. So we have an error, but since we're running Quarkus, it's very easy for us to fix that. I just go back here to my project. I open, for example, my application properties file, and I say that, oh, greeting should be, let's try to add some French, bonjour. And I save the file, go back here to my browser, and my configuration property is already there. How long did Quarkus take to reload? 155 milliseconds. So I think that's the experience that we can expect from Quarkus, taking approximately 100 milliseconds to reload. And that it is as good as it can be. So bonjour, and of course, what else can we change here? I could say that greeting, I could provide, just in case I made a typo, I could provide, for example, a default value. But instead of providing a default value, what can I do? I want to show you that since we're using Java 8 Plus and the microprofile config API, I can use also Java optionals as the property type. So if it's an optional string, I can say it's greeting. Or else, I can return another thing. I can say aloha. Let's try to add some Hawaiian here. And save the file, go back here, reload. I still have bonjour because I did provide the property. But suppose that I made a typo and my application properties now it's not greeting anymore, it's greeting 2, which is clearly a typo. I'll go back here and, oops, the value is absent. I'm providing a default value, aloha, and it's still running. So I have a static string, I have a property file providing, but it's just still a synchronous old style JAX-RS endpoint. Can I be async, for example, to be able to handle more requests at the same time? Of course you can. So let's try to create here another get to rest endpoint, and I want to produce media type dot text. Plain, text plain, and let's try to add a different path. I'm going to /async and public completion stage of string hello async. And how do I create a completion stage? Well, you can do that, for example, using a completable future. And I supply async here. I need a supplier, so I can use a very nice lambda. And I can return here, hello, I'm async. And if I just do this, save the file, refresh, I have an error because maybe I added an additional parenthesis or I forgot a semicolon. But thanks to Quarkus, I have very nice error message. For example, I can read here, and example resource line 30, you missed the semicolon. But since we're using Quarkus, I can just go back here to my IDE, I add this additional semicolon, I remove this additional parenthesis, I save the file, reload, and it's already here. Let's go to the async endpoint. And yes, hello, I'm async. So you can see that Quarkus has a very fast init feedback loops. You just save the file, see the feedback. If you made a mistake, if you made a typo, for example, you go back, fix it, and you already have the results available, okay? So this is one of the nice features of Quarkus. But you might argue with me that Quarkus is only super fast this way because it's just a plain old static like REST endpoint. What can we do with Quarkus that would make it more enterprisey? And no true enterprise Java application is enterprisey enough if you don't add a database connection to that. So let's try to add this. In Quarkus terminology, we call these new capabilities of your application as extensions. And of course, you can run a Maven plugin, you can edit your pom.xml file. But I want to show you one of the most recent features of Quarkus, which we just released this week, which is the live reload of Maven dependencies too. So if I could use my IDE, for example, add extensions to my project. And what capabilities do I want to add to my project? I could add, for example, I want a database and I want to use JPA, for example. I could add Hibernate as my JPA implementation. But I also want to show you a nice API, a new API that we created with Hibernate, which is called Panache. So let's try to add Panache. I need a JDBC driver too, so let's try to add some MariaDB. I also want to provide some JSON. I think I already added that. I want to be able to test my API endpoints using a very nice UI, so I don't need to create some CLI commands. So I'm going to add the OpenAPI extension. OpenAPI extension. And let's try to see. I want to provide some validation for my endpoints, and it should be good for now. I just hit enter. You can see that my IDE here is just running my Maven, Quarkus Maven plugin. It successfully added my extensions because you can see emojis for the win. And I already have these extensions in my class path. So what else can we do? Let's try to first configure my database connection. And before we do that, I want to show that I already have a MariaDB database running here, and it's empty because if I show the tables, I have nothing there. So how do I configure a database using Quarkus? Probably the easiest way these days is to provide you some properties. So if I just type here the magic strings, I can see this is URL. My URL is going to be SparksJoy. The database driver is correct. The username should be SparksJoy. Password SparksJoy too. And the database generation algorithm should be the update, which never use this in production because I have like bad times using this feature in production. But since we're just a demo, we're just doing some lab hacking, it's perfectly OK for me to update my database schema as I'm coding. So that's the beauties of using live coding with Quarkus. You just can create automatically, just saving the files and refreshing your web page. Okay, so I think I successfully configured my database connection. So next step is for me to create here a new file, and let's try to create a new entity. Let's create, for example, a new entity called developer because we are all developers, and of course, we love developers. Quarkus love developers too. So I have a developer, and I would need to provide an @entity. Entity, okay. And if I were using traditional JPA, I would probably need to provide private long ID. I would need to make like an @ID and then @generated value. But this is just boring. Since I'm using JPA and Quarkus, I want to show a new API called Panache. So how do I use Panache? Panache. I'm using Panache just by extending the Panache entity. And what is Panache? Panache in French means brave, bold, courageous. And that's the official explanation for using Panache. And my particular version of why it's called Panache, it's because most of the Hibernate team, guys from the Hibernate team that were doing this feature are French. So they got to choose the name. So they got a French word for that. So that's why it's called Panache entity. And what does Panache bring to Java developers? With Panache, and you know, in the Java development world, traditionally, if we wanted to use persistent features, we would create what we called in the past DAOs, or what we call today repositories. We're using domain-driven design terminology, and we're calling that repositories. So repositories are one style of persistence when dealing with databases, for example, in the development world. What we don't know, at least what most Java developers are not used to, is that we have another persistent style called active record. And if you ever use it, for example, Ruby on Rails, or if you ever use it, Play Framework in the Java space, you know that active record style is a persistent style where you blend your entities with the persistence methods. I know for complex business models, maybe it's better for you to still use repositories. But if you're designing plain and old simple CRUD applications, maybe active record style, it's easier for us. So I want to show you the new feature, active record, which could be done in the past. For example, if you ever, I tried to use that, for example, with Springs many years ago. But the problem is that you would need to add some XPXJ features or need to install Java 8 in your application, which would make it very complicated. And to be honest, it was very slow in production. That's why nobody was using that anymore. But with Panache, you don't have to worry. It's going to be super fast, super simple, and super small. So I don't have to declare the ID anymore because with Panache is already there. Now we are going to provide some properties to my entity. And how do I declare a property in JPA? Private string name, and probably later we'll need to provide the getters and setters. For example, get name, but it's just boring. And think about that. If I have to declare a private property, and for each one of them I'm providing getters and setters, you really don't have like true encapsulation. You're exposing your internal state anyway, so I know it's very opinionated, but that's one of the possibilities. You can still code the old Java Bean style, or if you're using Panache, you can be bold and courageous, and instead of using private properties, you can use public properties. And as I said before, it's very opinionated, but don't worry. You can code like a public property, but you will run as a private property. Okay? It's code like a public field, run like a private property, because at build time, Quarkus and Panache will translate that into a private field and will generate the getters and setters for you, because we know most frameworks these days still use the Java Bean specification. I mean, we need those getters and setters. Let's use the new brave and bold way, which is using a public field, public string name, and it should be good. I have an entity, a JPA entity, and since I'm using trying to create a microservice, let's try to expose this as a REST endpoint. I'm going to create a new class, a developer resource.java, and I'm going to create this package name, Red Hat developers, and I'm exposing this pash should be /developer. Okay? But instead of producing media plain, I want to produce application JSON. And instead of returning, let's return a list of developers. And the method name should be something meaningful like developers. So here's where the magic happens. If I wanted to create that with JPA, I would need to create a query, I would need to inject an entity manager. But since I'm using Quarkus and Panache, the easiest way for me to retrieve all of the developers in my database, for example, would be type developer dot list all, which again, you would never do this in production because you would retrieve the fetch the entire database into memory. But since it's just a demo, and we will have like 3, 4, 5 developers in my database, it's pretty okay. In production, you would have to page the results or filter the results. And of course, all of this is possible with Quarkus too. But it should be good enough. And if I go back here to my browser, localhost, and remember, we added Maven dependencies to my project, and I didn't stop and start anything. It's the first request that I'm issuing to my server right now. Localhost 80 developer. Console is here. And if I type enter, this is where part of the magic starts. Quarkus detected that you add additional dependencies to your pwn.xml. So your dependencies changed. Quarkus stopped the services, rebuilt the project, add the new dependencies, and restart it again. And this time it took a bit more, but just because I had added more dependencies. And with this time, we're also adding the time that we had to that we spent creating a database connection. So here we took more than 1 second. But I agree it might be too slow for whoever is using Quarkus. But as I said before, things improve as the more we use Quarkus. So it's slow just because we just had to add more dependencies. And I'm already listing the developers that I have in my database. I'm using a plugin, a Firefox plugin. But if you want to see the raw data, you can see that you have an empty JSON array because I don't have any developers in my database. And go back here to my database CLI. If I show the tables, yes, the tables are already there. And if I desk developer, you already create an ID and a name. And if I select star from developer, I have no developers. The easiest way for me to test my REST endpoint would probably to try to insert manually some developers, but that's just boring. Since we're using Quarkus, I would say that the easiest way for me to test this REST endpoint is to create another post endpoint, so I can insert the entities into my database using my, my web server. So if I go back here to my code, instead of just a get endpoint, let's try to implement a post. And post, endpoint 2, and this one is going to produce media type.json, and it is also going to consume media type.json. Okay? And my particular endpoint is going to be public. It's going to generate a response, and I'm going to say new developer. And I'll receive a developer as a parameter, because I'm going to provide that on my post request. And I'm receiving a developer. If I want to make sure that I'll persist the developer, I just need to set my developer ID to null. And call developer.persist. You see, that's active record style. The persistence methods are mixed, like are embedded into my entity. So I call developer.persist, and I can say return response dot created no code status, and I can say status dot created dot entity. It's going to be my developer. .build. Okay, let's try to break it to make it more readable. So I have here response, status created, developer entity build. It should be good. How do we test this endpoint? Well, traditionally you would need like a Firefox plugin, you would need a Postman, or you would need to create a very complicated CLI command using curl to create this REST endpoint. But since we're using Quarkus, and I added the OpenAPI extension, I can just go back here to my browser and localhost 8080 and type Swagger UI. So the Swagger UI is consuming the OpenAPI schema that is automatically generated by Quarkus, and you can see that the schema already has these endpoints: get developer, post developer, hello, and hello async. The one that I'm interested into is the post developer endpoint. So I have the post developer, and you can see that I already have the schema here for my request. And the interesting button is the try it out. So let's try it out, my newly created post endpoint. I already have the schema, and let's try to create a new developer. So I'm going to create myself, Yanaga, and execute that. And since I executed that, I can see the return here. If I did everything correctly, I should be receiving a 201, saying created, but 500. I made a mistake. And of course, Quarkus always generates very nice error message. So if you read the entire error message, the complaint is that, well, you're trying to persist something to the database, but you didn't provide any transactions. So you have a bug in your code. But don't worry. We're using Quarkus. It's super easy to fix this bug. I just go back here to my IDE. I add transactional. Save the file, and it should be working. Let's go back here to my Swagger UI, and now execute the method again. And you can see now I have a 201. It was created. I already have an ID 1, and it's called Yanaga. Let's try to add more here. I have Burr here is also in the audience. And let's try to execute. Let's try to add my colleagues too. So I'm going to add Alex. Oops. Execute again, just because I need to populate more developers. I'll add my Indian friend too, Kamesh. And execute. And if I go back here, yes, I already have like 4 developers persisted. And you can see that both my get and my post endpoint are running successfully. Okay? And that's how easy, how fast can it be for you to run Quarkus. And how long did Quarkus take this time? Well, it really depends. Sometimes it takes 200 milliseconds, 400 milliseconds. But you can see that's very fast startup time. For somebody that used to have to wait for minutes to see the feedback, with Quarkus, it's just a matter of milliseconds. Okay? So my post endpoint is working okay. And you can see that my database, I'm not faking anything. If I select, I already have my developer persisted here. Let's try to add another property to my developer. Go back here to my developer entity, and you know, every Java developer these days have like their favorite framework. So let's try to add a favorite framework here. And of course, since it's just JPA, I can provide the standard JPA annotations. I could say that, well, let's provide a column, for example, and the column definition should be something like varchar 255. And I could even provide a default, because everybody's favorite framework these days is Quarkus. So I just save the file. And it should be good. It's just public priority. I go back here to my REST endpoint, refresh the browser. And yes, it's already updated. Everybody's favorite framework is Quarkus. Go back here to my database. It's already there. And remember when I said that with Quarkus you code like a public field, but it runs like a private property, a private Java Bean property. Suppose that I want to change the behavior of my getter. Maybe it's a bad idea, but I'm not judging. I'm just saying that you can do that. And now I have a new business requirement. I say that the developer name should always be lowercase. So if I just type here get name, you can provide your own getters and setters. So Quarkus won't generate another one. It will use the one that you provided. And I'm typing here that it's too lowercase. I just save the file, go back here to my browser, and you can see that everybody's lowercase. Now I have another business requirement saying that the favorite framework should always be uppercase. Oh, don't worry. I just go back here to my IDE and create a new getter, get favorite framework. And favorite framework should be always to uppercase. Save the file, go back here to my browser, refresh, and everybody's uppercase. So if you're using Quarkus and Panache, well, as I said before, you don't have to worry about using public fields, because behind the scenes, everything is still a private property. It's opinionated. If you want to keep your old style, you can keep it. We don't judge. But if you want to try the courageous way, you can use Quarkus and code like a public field. What else can we do with Quarkus? For example, I could say that the name of the developer. I need to add some constraints here. So let's try to use the validation API. And I can say that the minimum length of the developer name should be 3. So if I just save the file and go back here to my developer resource, and I say that, well, if you're trying to post a developer, it should be valid. OK? Valid. And now it's just added this very simple validation. I can go back here to my Swagger UI and try to add a new developer. So I'm going to post this developer, and the name is developer is going to be me. Oops. Did I say try it out? Yeah. Me, and I execute that, and I have an error. 400 bad request, which is the right response error if you have a bad entities being sent to your backend. So you can see that Quarkus is automatically integrated with Hibernate Validator, JPA. So I have a constraint here, and Quarkus is telling me, well, you have a parameter violation. The name must be greater than or equal to 3, which is a very nice error message. You might argue with me about that. So yes, you have validation embedded in your framework. Okay. What else can we do with our entities? You said, I didn't like this active record style. I prefer the old way, the repository style or DAO style. Can I do that with Panache too? Of course you can. And of course, we help you to create your own repositories. So for me to create a repository, I just have to go back here, create a new file, developer, repository.java, and let's try to create a new class. So I create a developer repository, and the magic happens when I say implement Panache repository of developer. OK? And I just need to make sure that it's going to be a bean. So I say application scoped, and it should be working. And if I want to create custom methods, it also works, because the Panache repository interface already has a lot of helper methods. So we already implemented for you persist, merge, find, delete, all of this stuff. But sometimes you want to create your own custom queries. Suppose, for example, that I want to create a public list. I want to return developer. And I want to find any other Brazilian in the room. Okay, 3. Lots of Brazilians here in Ukraine. You can imagine that. So I'll find a Brazilian Japanese. Any other Brazilian Japanese? No, okay, then I'm still unique. If I find Brazilian Japanese, if I want to provide a custom finder method, I can just type like here, find, and I can provide a custom query. And you know, here we have like JPQL query syntax. If I wanted to provide that, let me put it higher here. I would say select star from developer where developer.something, but since Panache knows that you are in a developer repository, you obviously querying developer entities. So you can omit everything and just say, well, where the developer name like, and I'm going to create a concat string here. It's going to be concat and first parameter, concat again, and here, close the string. I always mess up here, and I want to provide a parameter, Yanaga, and list. Okay, if I type it everything correctly, I should be able to return only the Brazilian Japanese on the database. Should be working. So let's go back here to my developer resource, and on the get methods, let's try to add another parameter. For example, I had a query parameter, and the name would be Brazilian Japanese. The type is going to be Brazilian, Boolean, Brazilian Japanese. And if I have the parameter and it's true, I want to return, oh, let's try to inject my repository. So I can just type here developer repository. I'm going to inject it and return developer repository, find Brazilian Japanese, okay? And I guess, or else return everybody. Let's see if it's working. I go back here to my browser, localhost 8080. Yes, it's returning everybody for me. But if I add a special query parameter, which is called Brazilian Japanese equals to true, returns only myself, the only Brazilian Japanese in the list. So yes, I can do developer repositories. And you can see you don't have to stop and restart everything. You don't have to wait for anything. You just send a request to your browser, and it's already there. That's one of the magics behind Quarkus. And to be honest, that's my favorite Quarkus feature because I don't have to wait anymore for anything. I can be super fast and super small always. Okay. So I added all of these features, and let's try to test more features. For example, let's go here and try to create another project. So another way for you to create Quarkus projects, besides going to the code.quarkus.io website, is to use the Maven plugin. And before anybody asks me, yes, we support Gradle too, but I'm a Maven fan. I like bad choices. So Quarkus, I can do Quarkus Maven plugin. And the latest and greatest version is 0.27 and create. So I'm going to create a new project. It's going to ask me for some properties. I can say Conrad Head Developers. Remote. Let's try to add the remote endpoint version, create a REST resource, yes please, and class name, yes, let's stick to the defaults. So if I go back here to remote, yeah. One additional features of Quarkus is that Quarkus is a perfect match for another technology called growl VM. So we can use my Quarkus project to generate a native executable using the growl VM compiler. So if I just decide here to run, I type the magic words package, and I enable the native profile. It's going to compile my project, and it's going to generate a native image using growl VM running on top of Substrate VM. So while it's compiling, because it might take some seconds, approximately 50 seconds in my machine, let's go back here to my presentation because I want to show you some numbers. And some common jokes about Java is that Java is super slow because, yes, it took forever to start up my application and warm it up. And Java applications also used to be memory hogs. They used to consume a lot of memory. But, you know, Java wasn't a good fit for this new cloud and native world. And to be completely honest, I've been doing Java development in the past 25 years, but in the past 5-6 years, I was really worried that I would need to learn a new technology before I retire. because Java wasn't fit for this cloud world. Because, and I've seen a lot of developers in the past 5-6 years moving from Java to other frameworks or technology, for example, Node.js, because you have this very fast iterative feedback loop, or moving to Go because you have a very small footprint, memory footprint in production. It's very fast to start up. So Java wasn't fit. Imagine, in the past, when Java was created, you used to have a single server, a single instance. You would have a dedicated server to run your application. You would start your application server, and that application server would run for months without being restarted. So in the past, in the beginning, Java, we traded memory consumption and startup time for performance. And that's why the JVM became probably the fastest runtime environment in the world. But in this new cloud-native world, we don't scale up our servers anymore. We scale them horizontally. Now I don't want a single instance. I want like multiple instances. I want to be able to like scale to more instances, so I can, when I'm receiving like millions of requests right now, I want to be able to spin up new instances, and this new instance should be able to handle those requests. But if you're using Java, you have one instance, then a million requests are coming. Well, until your applications start and get warm, that million requests, they're already gone. They already time it out. The end user already received an error, for example, and they move to your competitor. That's why Java wasn't fit for this cloud-native world. And of course, if you think about serverless, it's even worse because you have nothing running. You have a request coming. Well, until I wait for my application server to start up, my request is gone. So that's why Java wasn't fit. But as I mentioned before, I was worried that I would have to learn a new technology before I retire. But thanks to Quarkus, I'm pretty sure that Java will still be relevant in the next 25 years. So I can retire still being a Java person. And why Quarkus? Well, Quarkus was created to try to solve this problem of Java is not fit for this new cloud-native world because it's slow and consumes a lot of memory. And of course, we also already have context. So Quarkus had this approach in mind when being developed. I need to be fast. I need to very small memory footprint, and it also I need to be enabled by containers. I don't know how many of you are already using containers in your applications, but containers also is one of the things that I'm pretty sure that are here to stay. In fact, container technology is so important these days that I'm pretty sure that in 5 years, nobody will be talking about containers anymore because it will be the default packaging for applications. So it's like having a TV. Nobody says that, oh, I have a TV at home. Well, it's just commodity. Everybody has a TV at home. Well, at least used to be. These days, the kids don't even want TVs anymore. They just want the tablets to be watching their Netflix series. So here, I'm going to show you some comparisons. And just please be aware that these numbers are already outdated because these numbers are related to the first release of Quarkus, and when talking to the Quarkus performance team, they told me that these numbers are not true anymore because JPA doesn't add any overhead to your Quarkus application anymore. So whether you're using just REST endpoints or REST plus JPA connecting to a database, the performance of your application, the memory footprint of your application will be very, very, very close to just your REST endpoints. So have in mind that Quarkus right now is even faster and smaller than these numbers that I'm going to show you. But let's try to make some comparisons. For example, Quarkus, when running with growl VM, with just a REST endpoint, is going to consume 13 megabytes of RAM. If you're running Quarkus with hotspot VM on OpenJDK, it's going to consume 74 megabytes of RAM. And your traditional cloud-native stack that you're used to is going to consume at least 140 megabytes of RAM. So your Quarkus application in production, depending on the scenario, can be more than 10 times smaller than the traditional cloud-native stack that you're using. Okay, that's for REST. Let's try to add some JPA, not because Quarkus is slower, but because other frameworks are slower. So if I have Quarkus plus growl VM, and remember, we're better than this right now, with adding JPA to the equation, Quarkus is going to consume 35 megabytes of RAM. OpenJDK is going to consume 130 megabytes of RAM. And the traditional cloud-native stack that you're used to is going to consume 218 megabytes of RAM. So these are some typical memory consumptions. And why are we emphasizing memory? Because in most of the scenarios today that we have in cloud-native applications, memory is the most expensive resource that we have in the cloud. And why is that? With CPU and network, for example, usually you can share over time. Storage is super cheap, but with memory, if your application has requirement of a heap size, or for example, a resident set size of 2 gigabytes of RAM, if you need 2 instances, you require at least 4 gigabytes of RAM. And you're going to pay for this price whenever your application is running. So that's why memory is so expensive. Let's try to get some other numbers, because here I'm only comparing resident set size. Let's talk about time to first successful response. And I'm not measuring startup time, because startup time is almost like cheating. Because, you know, we have some other application servers or frameworks, for example, that they say, let's try to do everything lazy. So just to be able to show you a very small startup time. But whenever you issue your request to your application server, well, the application server needs to initialize everything and respond to that. So in production, lazy initialization is not feasible, because you have to pay the price anyway. So what we're truly measuring here is how much your application server or your Quarkus application takes to start up and respond successfully to the first request. So we're not measuring startup time, we're measuring how much does it take for your application to respond successfully to the first request. So some numbers, if using running Quarkus on growl VM, we will take 14 milliseconds to respond. If you're using Quarkus on OpenJDK, we're going to consume 750 milliseconds. And if you're using a traditional cloud-native stack, it's going to take at least 4.3 seconds. Okay? Add JPA to the equation. Remember, it's still old numbers. With Quarkus, we're much closer to these numbers here. Add JPA to the equation. We're going to take 55 milliseconds to reply successfully to the first request. On top of OpenJDK, it's going to take 2.5 seconds. And your traditional cloud-native stack is going to take so long that I had to scroll the picture. It's going to take at least 9.5 seconds. That's how fast Quarkus is when running in production. Okay? And you might be wondering, why is Quarkus so fast and so different from everything that was done in the past? Well, the magic is that Quarkus is not lazy. Actually, Quarkus is super eager. Quarkus does everything ahead of time. And just for you to be able to compare, any traditional Java application framework that has been built so far used to do these things at startup. For example, if you use annotations in your project, it's very likely that, yes, you have XML files, you have properties files, you have JSON files, YAML files in your project. They are responsible for the metadata of your project. And to be able to discover these resources, you need to do, for example, class path scanning. You need to scan for annotations. You need to look for these files, for these resources in your application. You need to scan for that. After you did that, for example, you need to parse those descriptors, which means that you need to extract the metadata from the annotations. You need to extract the metadata from properties file. You need to extract the metadata from XML files. After you have all of your metadata, you need to generate your meta model, which means that if you're creating beans at runtime, you need to see, oh, these beans need to be injected into this other bean. This bean needs a transactional proxy, so I need to create a proxy here. And this proxy needs to inject to the other bean. You have to compute all of these things, and after all those things are instantiated to memory, then you start your servers, you open the socket, your web server is listening to the port, it's ready to listen for requests. That's a traditional Java application. That's what has been done in the past 25 years in the Java space. With Quarkus, well, whenever you're starting your application, the only thing that we have to do is start the services, because everything is already ready. That's why Quarkus is super fast. We take only a few milliseconds to start our services, because everything else was already done at build time. Okay? So the magic behind Quarkus is not in the runtime. The magic behind Quarkus is the Quarkus plugin. Because what we are doing, we're doing all of these, and we're generating bytecode directly using a library called Gizmo, so you can have a very highly optimized bytecode. So at runtime, we just start the services. So and why does Quarkus consume so very such a small amount of memory? Well, Quarkus is super fast because of this, and it's even faster, and it's also super small because whenever you're scanning for annotations, you need to load the reflection classes into memory. Whenever you have to parse a properties file, you have to load the class of the properties file into memory. Whenever you're reading an XML file, you need to load the XML files into memory, even though you'll be never consuming those classes into production. They're only required for configuration. But for traditional frameworks, you're always paying the price because those classes will be into memory until your application goes down. With Quarkus, you don't need to load any of this stuff. When you're running in production, you are only loading the classes that are required to fulfill your production requests. That's why Quarkus is so small. And after all of this explanation, I believe that my build is done here. Yes, my build is successful. Let's try to see what happened. I have the target here. You can see that I generated, I have a jar, traditional jar. I have a runner jar, which is a executable jar, which is consuming approximately. My jar has 4.6 kilobytes of disk space. My run executable jar, where is that? Oh, disappeared. But my executable image running Maven, running growl VM is consuming 22 megabytes of disk space. Let's try to run this application. And it has a complaint because I already have another application running. Let's try to switch the ports. You can see, yes, firewall, I want to accept this request. And you can see that my Java, my Quarkus native application took 10 milliseconds to boot. And let's see if my application is running properly. So I go back here, localhost 8080. Yeah, oh, 8080 is the old one, 8081. Yes, it's running. And how much memory is Quarkus consuming? Well, let's try to improve the numbers. I want to say, did you ever imagine the day where your Java application would be able to run in just like 6 megabytes of heap space? Well, 6 megabytes, 6 megabytes, 6 megabytes. Let's see if it works. I tried 4, but I think it doesn't run. It's listening, and yes, it's running. Let's go to /hello. Yes, it's still returning. How much memory, how much resident set size memory is my process consuming? Let's try to look at that. My Quarkus application is running in production, consuming only 18 megabytes of resident set size. That's how small your Quarkus application can be if you add growl VM to the equation. But remember, Quarkus is always super fast and super small. If you need to be even faster or even smaller, maybe you can compile your Quarkus application using growl VM. Okay? And how much time do I have? Half an hour? No? Well, until somebody kicks me out. So let's go back to my IDE. Let's see what we can do with the remaining minutes that we have. So who here uses, for example, Spring Boot? Okay. So we know that most of you are familiar with Spring APIs. And you might be wondering, I'm not a fan of the JOXRS syntax for creating endpoints. I'm not a fan of the panache thing. Maybe I want to use something like more, I'm used to my APIs. I don't want to change. Because, you know, Java developers, any developer actually, is very opinionated, very passionate about their APIs. So can I still reuse my Spring full skills using Quarkus? Well, the answer is yes. So why don't I try to add more extensions to my project? I want to try to use the Spring Web API here and the Spring Data API too. I added these two new extensions. I'm running here my Maven plugin. Build success is added. So how can I use these skills? For example, let's go back here and try to create a Spring REST controller. I want to create a new file, and I want to create a developer controller. And I type a class, and I want to say that this is a REST controller. And my request mapping is going to be the path. It's going to be /another developer. And here I can say I get mapping public list developer. And if I still want to use Panache, for example, return developer.list. List all. Okay, here I'm mixing. I have a Spring web endpoint, but I'm using the Panache active record style to retrieve the queries, and let's see if it's working. If I go back here to my REST endpoint, localhost 8080/another developer. Yes, it's working. So if you want to still use your old style Spring APIs, yes, you can run on top of Quarkus. And can I use, for example, Spring Data, which is one of my favorite projects from Spring? Yes, you can. So let's try to create here another developer repository. And if I create a new interface here, I just need to say, well, this one extends JPA repository. JPA repository, and it's going to be a developer, and ID is long. I save this guy, and if I'm my developer controller, I don't want to use this. I need to, let's try to an autowire. Constructor injection works, but I'm just lazy. Okay. And I say another developer repository, and I have this autowire. And instead of returning here, I can, well, return developer repository.find all. You should be returning everything for me. And I go back here to my browser, refresh, and yes, it's still working. Can I use custom finders in my Spring data repository? Of course you can, because you can go back here to your repository and say, let's type public list developer and find by name and string name. Okay, I created a custom finder here in Spring Data, and instead of find all, let's find by name, and I'll add myself again. Save the file, go back here to my browser, and yes, it's only returning myself. So you can still use your favorite APIs that you used to on top of Quarkus. And another question is that, does it mean that you're running a Spring on top of Quarkus? Well, no. We wouldn't benefit from running Spring on top of Quarkus because the Quarkus part will be super fast and super small. The Spring's part would be fat and slow as you used to. So what we're doing here is that we're getting the metadata associated with the Spring APIs, and we're providing our own implementation. So you can run your Spring APIs on top of Quarkus as a super fast and super small application, which leads us to another question. Can I run anything on top of Quarkus? Well, think about Quarkus as a framework for running other frameworks so they can be super fast and super small. Okay, so with Quarkus, since the very first release of Quarkus, we already supported all of these other frameworks. So you can be reactive using Vertex. Of course, you can use JPA. You can use JOXRS using your Easy, Camel, Microprofile, Neti, Kubernetes, OpenShift, Jaeger, InfiniSpan. We have Kafka, we have all of the extensions on top of that. And since the first release, members of the community stepped up and contributed other extensions too. So, I want my favorite library to be super fast and super small too. Well, don't worry. You just need to contribute to your Quarkus extension. Because remember, Quarkus is super fast and super small because Quarkus does everything ahead of time. Quarkus gathers all of the metadata and it processes at build time instead of startup time. So if you create your own Quarkus extension and tell Quarkus how to get the metadata for your application at build time, you will be able to generate your application, use your favorite library that will run super fast and super small. So you just need to create your own extension, which is not such a complicated scenario. So, of course, we have the guides, we have the starters, we have the Quarkus source code available on GitHub. So you can check how you can create your own favorite extension. Okay. And over time, that's some of the things that I wanted to share you about Quarkus. I think that the next step, you should go to code.quarkus.io and try it for yourself. We have very nice guides on the website too. Of course, we would love your feedback. You would love your contribution. But the very first step is that after the session, you just open your notebook and you just try to load the new favorite website on the internet these days, which is code.quarkus.io. And thank you very much. Good. And I don't know if we have time for questions. We do. If anybody has any questions, I'm available.
So I'm really interested in these error messages because I just spent a miserable day with a plain old micro profile. So do you guys generate better error messages than are normally generated, or is that something that the plugin provider into Quarkus does, or how does it work?
For the error messages? For the compilation error messages, the Quarkus plugin that it's giving you the outputs. For the validation messages, for example, is something that is generated by the Hibernate validator extension. Okay, so it's depending. REST Easy is generated by REST Easy, so it's very much extension dependent. Okay. Another question there?
Does Quarkus support injectable components like Spring does?
Sorry?
Injectable components.
Injectable components? Okay. Yeah, we support the Spring annotations, but just to fetch the metadata, for example. For dependency injections, we are using Arc, which is our implementation, the Quarkus implementation of CDI. So whenever you have like an auto-wired, for example, or if you're using constructor injection, what we're doing is we're just fetching the metadata, but at runtime, we are using Arc to inject the components. Okay, so we support most of the metadata, but some things don't work. For example, if you have a bean factory post-processor in your class path, which you would expect to be able to inspect the beans, we don't support that because we're not running Spring behind the scenes. Okay, we're using the annotations just to fetch the metadata.
Thank you.
Yeah. Any other question? No? Well, then, again, thank you very much.